Physical files, as you have already seen, are the AS400 objects that store the actual data. Each file has a single record format that describes the structure of the records in the file. A physical file can have multiple members, with each member containing a portion of the file's records. To create a physical file, we first code the data descriptions using an editor such as Source Entry Utility. The descriptions are then saved to a source file. Next, we use the Create Physical File command to create the file. Let us look at the source files. A source file is like a container. We use the Create Source Physical File command to create the source file. This command creates a file with a fixed record format consisting of 3 fields: a source sequence number field, a source date field, and a source data field. Each line of code that we write becomes a record in the source physical file, and the entire description for a file is stored as a separate member in the source file. There are some naming conventions that are normally followed for source files. The source file used for storing data description is usually named QDDS-SRC. This enables the system to supply the correct object type to the editor so that interactive syntax checking can be done. For example, QRPG-SRC for RPG programs, QCL-SRC for CL programs, QCMD-SRC for command definitions. Also, the Create Physical File and Create Logical File commands take a default value of QDDS-SRC for the source files. Getting back to physical files, keep in mind the following tips when coding database files. File names, record format names, and field names should not exceed 10 characters. Only uppercase characters are allowed. The first character in a name must be an alphabet. The remaining characters can be numbers or any letter from the alphabet. The @ $, hash, plus, minus, and the underscore characters are also allowed. However, the @ $, and hash symbols are part of the national character set, which could vary for different countries and are hence best avoided. Also, you should take into consideration the limitations of high-level languages. For example, RPG 400 and COBOL 400 do not support the underscore character. This is a DDS coding sheet that you can use to code the data description before entering it in the system. DDS uses a position-sensitive format. Let us write a description for a physical file. Say, for example, we want to create a database of customer information. In the database, we will store the following information: customer ID, customer name, customer address with street, location, city, PIN code and state. Also, we would like to sequence the file on customer ID. First of all, we give a name to the record format. Say cust.fmt. We write this in columns 19 to 28. we write an R in column 17 to indicate that the entry in columns 19 to 28 is a record format name. Next, we define each of the fields in the record format but leave column 17 blank. If we want to use a keyed access path for the file, we write the name of the field in columns 19 to 28 and insert a K in column 17. In columns 30 to 34, we define the length of the fields. These have to be written right justified. In column 35, we indicate the data type of a field. For example, A indicates a character field, P indicates a packed decimal. Column 35 can be read differently depending on the presence or absence of an entry in columns 36 and 37. For example, when columns 35, 36 and 37 are all blank, the data type entry in column 35 defaults to character. But when columns 36 and 37 have entries and column 35 is blank, the data type entry defaults to numeric. Columns 36 and 37 are used to indicate the number of decimal positions in a numeric field. Column 38 is used to indicate the valid operations that can be performed on the field. For physical files, since both input and output operations are always valid, this field can be left blank. In case definitions for a field already exist in a previously defined file, we can avoid having to define it all over again by specifying an R in column 29. We also have to identify the file in which the definition exists, but we will see how to do that later. Columns 45 to 80 are used to define keywords that are used to enhance the functionality of DDS statements. We will see more about keywords in a little while. First, let us take a look at the different data types that are supported by DB2 400. The character data type. An A in column 35 is used to indicate the character data type. As mentioned earlier, if columns 35, 36 and 37 are all blank, the data type defaults to character. The hexadecimal data type. This is identified by an H. It is used for storing binary data such as bitmaps of images. Binary data type. Binary data is identified by a B in position 35 and represents a number as a base 2 value. It is normally used only when we need to share data with other systems. The packed decimal data type. This is the default data type for numeric fields. It is identified by a P in column 35. Also, when column 35 is blank and an entry exists in column 36 and 37, the field defaults to packed decimal. A 0 in columns 36 and 37 indicate that the field contains an integer value. In the case of fractional values, it can contain a number between 1 and 31 to indicate the number of digits after the decimal point. Let us see how the system stores the data when it is in the packed form. Half a byte is used to store each digit. The 4 rightmost bits of the low order byte are used to represent the sign. A value of 1111 indicates a positive value and 1101 indicates a negative value. For example, a 7-digit number like 1234567 stored as packed decimal field would require only 4 bytes of storage and would be stored like this. The number minus 1234567 would be stored like this. A 6-digit number like 123456 would also require 4 bytes. In this case, 1/2 byte would be unused. Hence, it is always better to use odd length packed decimal fields, as otherwise the system takes extra steps to maintain the unused bits. Zoned decimal data type. This is identified by an S in position 35. It uses 1 whole byte to represent each digit. Thus, a 7-digit number like 1234567 would be stored in 7 bytes like this. Floating point data type. This data type is identified by an F in position 35. It is generally used for scientific or floating point applications and is very rarely used on the AS400. DB2400 supports 3 data types to handle date and time: date, time and timestamp. In column 35, you specify L for a date field, T for time and Z for timestamp field. You should not specify a length or decimal position. The system automatically determines the length of these types of fields. A date field occupies 4 bytes of storage. A time field occupies 3 bytes and both have a fixed internal format. The timestamp data type takes 10 bytes of storage. It is normally used when you need to record the precise timings at which events occur. It has an external format as shown. Let us move on to keywords. When keywords appear at the beginning of the file before any record format definition, they are referred to as file level keywords. They affect the entire file. Here are some keywords. Unique. This keyword is placed at the beginning of the file and prevents 2 records in the same physical file member from having the same key value. For example, in our customer file, we should not have 2 records with the same customer ID. When duplicate records exist in the file, the FIFO, LIFO and FCFO keywords are used to specify the order in which duplicate records from the same physical file member are to be retrieved. The FCFO keyword specifies that records are to be retrieved in the first changed first out order. FIFO specifies a first in, first out order, and LIFO specifies a last in, first out order. These keywords cannot be used when the unique keyword has been used. Remember, earlier we had said that you could avoid defining a field that has already been defined elsewhere by putting an R in column 29. We use the reference keyword to identify the file that contains the field definitions. For example, here the cusref file will be referenced for the definitions of the street, location and city fields. Keywords that appear at the record level, that is either on the same line as the record format definition or before any of the field definitions, are called record level keywords and are applicable only to that particular record format in the file. Let us look at some of the record level keywords. The format keyword can be used when we want to use a record format that has already been defined in another file. We cannot define any fields when using this keyword and is hence generally avoided. The text keyword is used to specify descriptive text for the record format or field. The description is coded within parentheses like this. If you want to include an apostrophe within a string, then you code it using 2 apostrophes like this. Next, we come to field level keywords. These keywords are associated with a particular field and affect only that field. The column heading keyword is used to specify a column heading for a field that is used when generating reports or running a query on the file. The column heading can be a single, double or triple line. Here's a 2-line heading. The reference field keyword is also used to refer to an already existing field description. You should code an R in position 29. Let us look at some examples. Here we are saying that the name field has the same attributes as the cust name field in the new cust file. Here, the street field has the same attribute as street1 in format new fmt in old cust file. Here is another example. The referenced field city is in the same DDS source. The alias keyword is used to provide an alternative name for a field. The name can be up to 30 characters long and should begin with an alphabet. The subsequent characters can be letters of the alphabet, numbers, or the underscore character. Languages such as COBOL 400 and SQL 400 that support longer identifiers than the characters supported by DB2 400 can take advantage of the alias name. Suppose a new record is being added to the file through a logical file that does not contain all the fields in the physical file. DB2 400 will use the default value of blanks for character and hexadecimal fields, 0 for numeric fields, and the current date and time for date time and timestamp fields. The default keyword can be used to specify a default value for a field like this. Now suppose a new record is being added to the file through a logical file that does not contain the category field. DB2 400 will use the default value of A. Sometimes you might want a field to not have any value. For example, suppose the customer file has a field status used to indicate whether the customer is satisfied or not. This field could contain a yes, a no, or no value if the customer is unsure. A null is used to indicate that a field has no value. The allow null keyword is used to specify that a null value can be allowed for a field. You can specify allow null and then use default to specify a default value of null like this. The variable length keyword defines a character field as a variable length field. The parameter specified within the brackets indicates the number of bytes that is to be allocated for the field in the fixed portion of the file. This parameter can take on any value between 1 and the maximum length of the field specified in the columns 30 to 34. The date format keyword is used to specify the format for a date field. When an application requests for a date field, the field is converted into the format specified in the date format keyword before being passed to the application. Some of the different formats that you can use for the date field are month, day, year, day, month, year, year, month, day, Julian, and ISO. The default date format is ISO. You can also specify *job to indicate that the date format is to be taken from the job description of the interactive job from which the file is being created. The date separator keyword is used to specify the separator character for a date field. The valid date separators are slash, hyphen, period, comma, and blank. Here too you can specify that the format specified in the job description is to be used. The time format keyword is very similar to the date format keyword and specifies the format for a time field. Two of the commonly used time formats are hours, minutes, seconds, and the ISO format. The time separator keyword specifies the separator character used in a time field. Valid time separator values are colon, period, and blank. Some field level keywords can be coded in the physical file but have no effect on the file itself. These are edit code, edit word, check, CMP or comp, range, values, check message identifier. These keywords are referenced by display and printer files that use these fields. The edit code and edit word keywords are used to format output values so that it is easier for the user to comprehend. For example, an edit code Y is used to specify a format for the date field. If the SAL date field has the date January 15th, 1998, it will be printed as 01/15/98. Edit code Z is used to suppress leading zeros. If a 6-digit field contains a value 001234, it would be printed as 1234. Sometimes you may not find an edit code that matches your requirements. In such situations, the edit word keyword can be used. An edit word provides a template into which a number is inserted. For example, suppose the total amount field has a value of 99999999. To print in the format 999-999-99, we specify an edit word like this. The blanks indicate where the digits have to be placed. The check keyword is used to check the validity of data that is entered into an input-capable field. It takes the following parameters: mandatory entry to specify that the user has to input some data into this field. Mandatory fill to specify that the data input into the field should have the same length as the length of the field itself. And allow blank indicates that the user may leave the field blank. The compare keywords CMP or comp are also only effective in the display files that reference this field. These keywords test the validity of data keyed into input-capable fields by comparing it with a value supplied with keywords. The relational operators you can use with this keyword are equal, not equal, less than, not less than, greater than, not greater than, less than or equal, greater than or equal. The range keyword is used to specify a range of valid values for a numeric field. When the user enters data using a display file that references this field, the system will check whether the data is within the range 100 to 9999 and signal an error if it is not. The values keyword is also used by display files that reference the field in the physical file. Data input into this field has to have one of the values specified with this keyword. The check message identifier keyword is used to identify an error message that is to be issued when a validity checking error is detected on one of the following keywords: check, compare, range, and values. However, remember that DB2 400 does not enforce any constraints based on these keywords. A program that is directly writing to the file could put in a value that does not meet the validity checks specified. Next, we move on to the key field level keywords. These keywords define how DB2 400 should handle a field when it is used as a key field. The descend keyword specifies that the key field should be in descending order when the records are sequenced. Otherwise, the default is in ascending order. The other key field keywords are absolute value, unsigned, signed, digit, zone, and no alternative collating sequence. The descend keyword specifies that the key field should be in descending order when the records are sequenced. Otherwise, the default is in ascending order. When the absolute value keyword is used, DB2 400 ignores the sign of the key field when sequencing the records. The unsigned keyword is a key field level keyword that is used to specify that the field is to be sequenced as unsigned binary data when sequencing the field. Signed is a key field level keyword that is used to specify that the sign of the field is to be considered when sequencing the field. The digit keyword is a key field level keyword that specifies that only the low order 4 bits of each byte of the key field is to be used to build the key value. The zone keyword is a key field level keyword that specifies that only the high order 4 bits of the key field is to be used to build the key value. No alternative collating sequence. This is a key field level keyword that specifies that an alternative sequence should not be used for the key field.
Here is a listing of all the keywords you can use with physical files. You can click on any keyword to get the detailed information for that keyword.
Let us now see how to code and create a physical file. First of all, we use the change current library command to change the current library to the one in which we want to create the file, like this. Then we use the create source physical file command to create the source file. We can now start the program development manager using strpdm. We select option 3 to work with members. Then we supply the source file name and the library name. For members and type, we specify *all. This will display all the members in the source file. Finally, we press the enter key. At this point, there are no members in the source file, but later on, as more members are added, we will get a listing of all the existing members. We press the F6 key to add a new member. The system prompts us for the name of the member and the source type. Normally, we will give the source member the same name as the physical file we are going to create. The text parameter is for documentation purpose. We press the enter key now to take us to the editing screen. Here we enter the code for the physical file and press F3 to exit. The exit screen is displayed with all the values filled in correctly. From here, we press the enter key to go back to the Work with Members screen. The next step is to create the physical file. There are two ways of doing this. We can enter a 14 in the option field adjacent to the member name, or we can type create physical file command on the command line. Either way, pressing the F4 key will prompt us for the parameters of the command. Let us look at some of the parameters. The file parameter is where we specify a name for the physical file. Normally, we would use the same name as we have given to the source member. We use a qualified name to ensure that our file is placed in the right directory. The source file parameter identifies the file where the DDS source is stored. It has a default value of QDDS-SRC. The member parameter is where we supply a name for the member in the source file. This parameter has a default value of *file as the member name is normally kept the same as the file name. In the maximum numbers parameter, we specify the maximum number of members we want for the physical file. The authority parameter specifies the kind of authority that public should have to access this file. Finally, we come to the text parameter where we can code a description for the file. Once we have specified the parameters, we press the enter key to complete the process of creating the file. If there are no errors in the DDS code, the create physical file command will create the file with a single member. To add more members, we use the add physical file member command like this. If we want to add more members to the file than had been specified with the maximum members parameter, we can change the maximum members parameter like this. The change physical file command can be used to change many of the other attributes of the physical file even after it has been created. Next, we look at a special kind of physical file, the field reference file. This is a very useful tool for application development. Let us see how it works. Most database applications involve more than one database file. Many of the fields used by the application will appear in more than one file. Either you code the data description for the field in each and every one of the database files explicitly, or you could code the description for a field in one of the files in which it appears, and then the other files can then refer to this description. In a large application, either method could prove confusing. Field reference files provide a very convenient solution to this problem. It is a physical file that can be used to hold only field definitions. We can put the data descriptions for all the fields required by our application into a field reference file. All the database files will now refer to this file for data definitions. This method provides a consistency to our data definition and also reduces the probability of errors caused by incorrect definition. We code the field reference file just like we code the physical file. We have a record format name, and then we define all the fields that we want to include. We use the create physical file command to create the field reference file. The members parameter should be set to none so that DB2400 does not allocate any space for data records, since the file is not going to contain any data. After the field reference file is created, you can refer to it for data definition required in the database files that you will be creating. This brings us to the end of the discussion on physical files. Summary. In this chapter, we studied physical files in detail. We saw how to code the DDS for physical files. We looked at various keywords that can be specified for physical files. We also saw how field reference files could be used to bring about a consistency to our data definition.